5.2, solving systems of linear equations by substitution. Okay, so let's talk about the substitution method. So we've got systems of equations here in these examples. That means we have more than one equation. And we're going to solve, we're going to be looking for what does x and y equal to satisfy both of these equations. And same thing over here, okay? So what we want to do first, our first step is to solve one of the equations for one of the variables. That means I need to get either the x or the y isolated in one of these two equations, okay? And you could isolate the y in the second equation by subtracting 4x from both sides, or you can even isolate the x. You'd have to move the y, then divide everything by 4. But the x is already isolated in the top equation, right? So x equals this. So that x is already isolated. So if you already have one isolated, you might as well work with that. And the same thing in this one, the y is already isolated, okay? So this first step is done in these first two examples already, all right? So you might as well use the path of least resistance there. Okay, so then let's move on to the second step, and the wording is a little confusing, but I'll show you what I mean on this example. This says substitute the expression from step 1 into the other equation and solve for the remaining variable. Okay, so what that means in practice, I've got the x isolated here, so now I can take the quantity 6y minus 7, and anywhere in the system I can substitute that in for x. I can replace x with the quantity 6y minus 7. That's exactly what I'm going to do in the other equation. You have to substitute into the other equation. So I'm going to replace this x with the quantity 6y minus 7. Okay, and when you substitute, use parentheses. Okay, I replace the x with the quantity 6y minus 7, and since I have the parentheses there, that's going to help remind me that I'm going to need to distribute. Okay, so my next goal then is to solve for y, because now I've got an equation that only has one variable, and I can solve that then for y. So I want to first distribute, so that would be 24y, 4 times 6y, and 4 times negative 7 is negative 28. Okay, then I want to start combining like terms, and I can combine these into 25y. Okay, and now I want to combine the negative 28 and the negative 3. I also want to isolate the y, so I'm going to add 28 to both sides. Now I have 25y equals 25. And then finally divide by 25. And then y equals 1. Okay? Now, that is part of my answer, but it's not the complete answer. Often I see students solve for one of the variables and then move on to the next problem. It kind of feels like we're done because we found what y equals. But remember what we have here. These, if you graph these two equations, they would both be straight lines. And we're looking for the intersection. And the intersection is going to be an xy pair. So we need an x and a y. Okay? So I've got the y, but I still need the x, and that brings me to the third step. So I'm going to substitute the value of the variable found in step 2. So in this case, I found y equals 1. And I'm going to substitute that into one of the original equations and then solve. So I can pick. I can put in the top equation or the bottom one. It doesn't really matter. So I'm going to substitute into the top one here. So x equals 6y minus 7. Well, I know y is 1, so 6 times 1 minus 7. Okay, and then let's see, 6 minus 7, so x comes out to negative 1. Okay, and you could write this as an ordered pair if you wanted to. This would be the point negative 1, 1. So you could write it like that. Or for me, I'm fine with you just saying x equals negative 1, y equals positive 1. Okay. All right, let's try this next one out. So same kind of deal. The y is already isolated, so I might as well use that to my advantage. So y is equivalent to 10 minus 7x. So that means I can substitute 10 minus 7x into the other equation where the y is. So I'm substituting into the top equation here and saying, okay, 2x plus the quantity 10 minus 7x is going to equal negative 8, right? I substitute it in that top equation. Now, there's nothing to distribute here except a positive 1. So this would look the same without parentheses in this case. All right, and then I'm going to start combining like terms. All right, next I'd want to subtract 10 from both sides to start isolating the x. And finally divide by -5. Okay, and then a negative over a negative is positive. I've got a fraction here, so I want to make sure it's reduced, and this is reduced. And 5 doesn't go into 18 evenly. So we don't have a nice integer solution here. So if you tried to graph these and solve by graphing, it wouldn't work out very well. This one would actually work out pretty well because we got a nice round solution that's near the origin. But this one, it would be really hard to tell what the solution was by looking at the graph because it won't be right on the grid. Okay? So you can leave your answer as 18/5 for x, or you could use the decimal version, which would be 3.6. Okay? So either way is fine for me. Now that I've got that x, I'm going to go back to one of the original equations and plug in the x so that I can find y. Okay, so I'm going to use the bottom equation here, I think. So I'm going to write y equals 10 minus 7. Then I'm plugging in 3.6 for x. Okay, now I want to solve this. So let's see, I'm going to do -7 times 3.6. That comes out to -25.2. And then I do the subtraction, and I get -15.2. Okay, and now I have my solution, and you could write those as an ordered pair if you like. Okay, all right, these next two problems are a little bit more difficult because we have to isolate one of the variables. So I'm looking at this. Neither of the variables is isolated in either equations. So I want to pick a variable, and it doesn't matter which one, but I'm definitely going to use the x or the y in the top equation because then I don't have to do any dividing, right? It's just easier to isolate the x and the y in the top equation. So let's go ahead and do that. I'll isolate the x here. So to isolate the x, I would subtract y from both sides. So I could say those are equivalent, right? I just subtracted y from both sides. I can't combine these because they're not like terms. But now I've got something that x is equivalent to. X is equivalent to that. So that means now I can substitute into the other equation for x. And that's what I'm going to do. -3 times the quantity, -2 minus y, plus 6y equals 6. Now I've got an equation that only has y, so I should be able to solve this for y. So let's start by distributing here. -3 times -2 is 6. -3 times -y would be 3y. Okay, let's start combining terms here. Combining like terms. 6 plus 9y equals 6. And now we'll subtract 6 from both sides. 9y equals 0. And last step is going to be to divide by 9. And it seems a little weird, but 0 divided by 9 equals 0, right? 9 times something equals 0. That something has to be 0 itself. Okay, so it's okay to have 0 in the numerator of a fraction, just not in the denominator. All right, so there's my y coordinate. And now I'll go back to one of the original equations. I'm going to choose the top equation just because it's easier to deal with, smaller numbers. And I'm plugging in 0 for y. And there's not much work to do here because x is going to equal -2. And I've got my solution then. Okay. All right, let's try this last example then. So I want to isolate one of the variables. I think it wouldn't be too hard to isolate the x in the top equation or the y in the bottom one, but I'm going to choose to isolate the y in the top equation because it's already a positive y. So all I'd have to do there is add x to both sides. So then I have -4 plus x. Okay. Now I have this that I can substitute into the second equation for y. So I've got 4x minus the quantity, -4 plus x. Really important to use those parentheses because I'm going to have to distribute the negative here next. Okay, so I'm solving this now for x. I only have one variable. I can solve this for x. Let's get rid of the parentheses. Okay, now I'll combine like terms. I got those two x terms on the left. I can combine into 3x. All right, now I'll subtract 4. So 3x equals 6. Dividing by 3, I get x equals 2. Okay, there's half of my solution. Still need the other half, so I'm going to go back to one of the original equations. So I'll use the top one here. So I've got negative x plus y equals negative 4. And I already knew x is 2. Okay, so now I have negative 2 plus y equals negative 4. And that means y equals negative 2. Okay, let's try out a word problem then. Here we've got a drama club and a yearbook club. There are a total of 64 students in those two clubs. The drama club has 10 more students than the yearbook club. We're going to write a system of equations and then figure out how many students are in each club. Okay, so let's say that D is number of students in the drama club and Y is number of students in the yearbook club. So we're going to have to write two different equations. We're going to write one equation just based on this first piece. There are a total of 64 students in the two clubs. So then I can say D plus Y is going to equal 64. Pretty simple equation there, okay? And then the second part that says the drama club has 10 more students than the yearbook club. Well, so let's say that the drama club had 30 students. That means the yearbook club would have 20 students, right? So if you take the number of students in the drama club and subtract 10 from that, that's going to give you the amount in the yearbook club, okay? Or you could say the drama club would be the yearbook club plus 10. You could add 10 to both sides of that equation if you like. Okay, and now we've got our two equations, and we should be able to solve this using substitution. So first I'm scanning the two equations and seeing, is there a variable that's already isolated? And I can see there is. The y is isolated in the second equation, so I'm going to use that to my advantage. Then I don't have to isolate that. So y is equivalent to d minus 10. So that means in the other equation, where the y is, I can substitute in the quantity d minus 10, like so. And then I should be able to solve this equation for d because there's only one variable there. Okay, so this would look the same without parentheses. So let's just start combining like terms. D plus d would be 2d. Okay, got it down to that. And now let's solve for d. I'll add 10 to both sides. So 2d is 74. And then we will divide by 2. And then d is going to come out to 37. Okay. All right, so that is kind of part of my answer there. I want to put the answer in words, but that's what the d is going to equal. I still need to figure out what the y equals. So now I can go back to one of the two original equations. It doesn't matter which one, and plug in 37 for d. So I'll use this equation here. So I'm going to plug in 37 for d, and the y is already isolated. That's kind of handy. And then that means y is 27, okay? So let's put this into words. And then the drama club has 37 students. I'll just make this quick. Drama equals 37. And yearbook is going to be 27 students. Okay, so that's my actual final answer there. Okay? All right, that's it for this section, and I'll see you next time.